Math 2 students, you had a day off yesterday and we're back. It's Wednesday. This is the second lesson this week, 2.6.3, and today we're really going to be using Desmos for most everything we're going to do. I wanted to back up a little bit and look at our vertex form and look at these intervals of increase and decrease right here, because we skipped over this and we've already done all the other stuff. And I'm sorry, I forgot you can't see where I'm pointing. So we've already done this stuff over here. So we're not worried about this stuff because we already did it on a different lesson. We're only worried about the levels of increase and decrease on this. So I think, yeah, my pen is way too thin here. So I am going to make this bigger so we can see these numbers better, but I want to just draw your attention to the top up here in yellow. These notes go with the Edpuzzle video. If you are watching the Edpuzzle video and you don't have these notes open or printed out, you need to do that now before you continue with the Edpuzzle video, because they go together. These notes are half of your test grade. If you don't do your notes, there is no way possible that you can pass your test. So you need to make sure you get the notes and you get them turned in. And in the last video, I talked about 3 different ways that you could turn them in. So if you missed that, go back and watch yesterday's video. Or sorry, Monday's video. All right, so also, just like on Monday, there will be some questions embedded in this video about, I think there are 5 this time, and those will determine your grade on the classwork grade for today. Okay, let's get started. I'm gonna make this bigger. I think that'll do it. I did already go over to Desmos and graph this parabola, and of course it does have arrows. Okay, so what we're looking for is what we call the intervals of increase and decrease. And these are 2 key features that you will have in Math 3. We do a lot of key features in Math 3. That's a lot of what Math 3 is looking at graphs and talking about end behavior and domain and range and so on and so forth. There are some other key features that are going to be added in Math 3 that I'm not going to cover in this lesson or even the rest of Math 2. So this one is going to get you a little head start on Math 3 though. So increase and decrease. Here's what I want you to do. And in Math 3 we do other types of graphs. We're only going to do quadratics in this lesson. But we do graphs that might go like this in Math 3. So there might be more than one interval that we're looking at. Let me undo that. Okay, so intervals of increase and decrease. What that means is uphill and downhill to me. That's kind of what I tell my students to look for. So what I do is I tell my students, and I'm going to use a highlighter here. I tell my students to start on the left side of the graph, which you might be able to see that I've just put like a green dot there with my highlighter. Start on the left side of the graph and trace the graph from left to right. When you reach a turning point, stop. Okay, so if I'm tracing this graph from left to right, still going, still going, still going, still going, and I stop at that turning point. I stop at the vertex is basically what I'm doing. I was going downhill. As I was tracing from left to right, I was going downhill. So what I tell my students is that downhill direction, you need to think of that as a decrease. So decrease is downhill. So imagine you're like driving a car and you're going down this hill. That's decreasing. Your altitude is decreasing basically. Don't think about it as speed or anything like that, because your speed could increase. Okay, and then the other side, I stop at that vertex, and then I start going uphill. So that's my turning point. So then I start going uphill. So that purple is my interval of increase. So purple is uphill, sorry. So uphill is increase, downhill is decrease. So on a quadratic or on a parabola, there are only one of each. Okay, so there's only one of each. That needs to go away. Oops. There we go. So one of each. There's one increasing and one decreasing on a quadratic or on a parabola. What we want to do is we want to think about where does this interval start and where does it stop, okay? So look at your decreasing interval, the green one. Let's talk about that one. Get my green pen. So at the end of this interval, or at the left side of this interval, there's an arrow. Well, on a graph, an arrow means infinity or negative infinity. Well, here I'm talking about the x values, okay? So the x value because the arrow is pointing to the left, and it is pointing up, but as far as left and right, I'm looking for left and right. It's pointing to the left. So as far as the x values are concerned, this arrow over here is negative infinity. So it starts at negative infinity, and then where does it stop? Well, it stops down here at the vertex. I'm only looking at x values. So I'm not looking at this right here. I'm only looking at x values. So this point right here is -3. So my decreasing or downhill interval, and I do write this in parentheses, it starts at negative infinity and it ends at -3. I do use parentheses here. If -3 was included, I would actually use a bracket here, but I'm not going to do that because at the -3, it is neither going downhill or uphill. It's stopped. That's the turning point. So my decreasing interval goes from negative infinity and it stops at -3. Okay, look at the increasing interval, the purple one. From left to right, where does it start and where does it end? Well, from left to right, it starts at -3, the same place the other one stopped. And it goes forever to the right. That is positive infinity. So on the x-axis, left is negative infinity, right is positive infinity. So it goes forever toward positive infinity. Now, positive infinity and negative infinity, they always get parentheses. So all of these intervals are going to have parentheses. Let's look at another one. Okay, I went ahead and graphed this one as well. This was one that we had done. These other, again, you can forget about these. We've already done these on this graph. Okay, so let's look at our vertex first. So our vertex is at 4, 5, but for levels of our intervals of increase and decrease, we only need the x coordinate. So this is 4. The turning point is at 4. Okay, let's go ahead and trace from left to right. Okay, so you know what? I'm gonna do this one in green. Okay, so it starts here, and from left to right, I'm going uphill. So this green is my interval of increase. Okay, and then on the right side, or keep going from left to right, and this red, and I'm gonna put an arrow right there, is my interval of decrease because that's going downhill right there. And the green one, I'm going to put an arrow there as well. Okay. So interval of, let's look at the green one first. The green one starts at negative infinity. This is negative infinity on the left side. And it ends at the 4. So my interval is going to be negative infinity to 4. My red one, my decreasing side, starts at the 4. And it ends up, this arrow is going to the right. So this is positive infinity right here. So it goes to positive infinity. All right, so that's all there is to that. Now, again, sometimes we have graphs that look like this. So on this one, I would have positive, negative, it's downhill, and then back uphill. So I would have 2 levels of increase and 1 level of decrease. But on quadratics, it's just 1 of each. Last one, let's go a little bit faster. Okay, so these numbers right here, they don't matter. We don't need the x-intercepts. The only thing we're really looking for is the vertex, and I only need the x value. So 0 is the point right here, that turning point, okay? Let me get my highlighter, and left to right, starting right here, going downhill, And you know, it really depends on which way it opens, whether that left side is increasing or decreasing. So that was downhill, downhill is decreasing. And then the right side starts at 0, uphill, put our arrow there, that's increasing. I think it helps to identify which one's which first. So this is increasing over here. Let's look at the decreasing one first. Do that one in red. This starts at negative infinity and stops at 0. And then the increasing one starts at 0. Whoops. Starts at, to get the green, I think I hit the picture thing. Starts at 0 and it stops up here at positive infinity. And that's it. That's all there is to that. Okay, I think that's all we're going to do with that. Now we're going to continue where we kind of left off yesterday. So this one, this is just a little review again, and I did graph these. Let me find my Desmos. Let's see. Okay, so this is the red one that's being shown right here. The vertex is at 2.5, negative 2.25. The zeros, what we're looking for there is the x-intercepts. Let me move it over here. The x-intercepts are at 1 and 4. And you can write them like that, just don't put parentheses around them. Okay. You could also write x equals 1, x equals 4. A couple different ways you could do that. All right, the second one. Let's see which one is that. Oops. Okay, that one is right here, so in blue. All right, we can just look at this part right here. The vertex is at negative 5, negative 2. And because I don't have this like this, I keep having to bring it up. The zeros, let's figure out what those are. I'm going to say negative 6.4. And this one is negative 3.6. Okay, and then the last one is right here, I think. Let me make sure. Yeah, that looks right. Okay. Oh, let's see, let's find it. It's way up here. Here's the vertex. Negative 1.5. 9.5. And these you do put in parentheses because it's an ordered pair. The zeros on this one are, oops, right here. It doesn't matter how far zoomed out this thing is, it'll still touch on those zeros. Let's round these. Let's say negative 3.7 and 0.7. Okay. All right. So that was just a little bit of practice with the vertex and zeros. That's it. And we used Desmos. We didn't factor these and find those, the vertex and the zeros. Okay. This is some of what we did yesterday. The height in feet of an object, t, seconds, oh, it should be t seconds after it's propelled. That comma should not be there. T seconds after it's propelled straight up from the ground with an initial velocity of 85 feet per second is modeled by h of t equals negative 16t squared plus 85t. Okay, so this is like, holy moly, how am I going to solve this thing? But you got to just take it one step at a time. Let's look at the parts. Okay, so first of all, we've been given this equation right here. So that makes it a little bit better. Okay, so that's kind of our base equation, right? So we can really kind of ignore the rest of it. Okay. It is telling us that this is our equation, and what we can do is go over to Desmos and graph it. They're asking us approximately when will the object be at a height of 50 feet. So let's go over and graph this. So this is another one of those that it's so skinny when you first graph it that you have to go back over this wrench. And I actually changed, I changed my x-axis, but it didn't, I changed it like -5, +5, but it changed it to 9, -9 and 17, which is fine. It works. It's just a little, it's still a little bit tall. Let me see if I can change this a little bit more. See what it'll do. Okay. Yeah. That, I mean, I think that makes it a little bit easier to deal with, and it makes it a little bit easier for me to get a snippet of it. So let me do this. Let me see if I can get a picture of it and put it over there on the PDF. Let's see. Yeah, that might work. Let's see if I can, maybe I can move it around a little bit if I need to. Okay, so it's asking, when will the object be at a height of 50 feet? Well, that's really hard to see right there, so I'm actually going to go back over to the graph itself. 50 feet is going to be right here, if you can see where my cursor is right here. And I'm going to just follow that over. So right around 0.6 seconds, something like that, is when it's going up, and it'll be at 50 feet going up. So about right there. Let's see, we can actually touch that. So it's about 0.7 seconds. Okay, so I'm looking for the Y value to be right at 50, as close as I can get it. So I'm gonna go back over here, and I'm gonna enter. It will be there at 0.7 seconds, but that's going up, and then it's gonna be there again. It's gonna be there at about 4.6 seconds also, and that's when it's coming back down. So it doesn't say coming down or going up or coming down, so we need to list both of those. 4.6 seconds, and this is going up, and 4.6 going down. All right, B says, when will the object ever reach a height, or will the object ever reach a height of 120 feet? And if you look here, the vertex is at 2.6 and 112, so the answer would be no. 112 is the highest that it reaches. Whoops. See if I can move this thing. Okay, what is the maximum height? 112.9. And then at what time does it reach its maximum height? Well, let's go back over to Desmos because it's really hard to see it on this little bitty graph. So it reaches it, oh, never mind, I'm sorry. The X value, 2.6 seconds, is actually when it reaches its maximum height. So just look for the vertex, 2.6, we'll say 2.7 seconds. 2.7 seconds. Okay, I'm gonna move this up out of the way, and then for the next one, I'm going to go ahead and I'm going to try to look at these on a split screen. If it doesn't work, I'll switch back and forth again. This time it's -4.9 t squared. That's meters. T squared tab plus 4t plus 10. Let's see what this looks like. Okay, I think we might be able to actually see this one. I'm going to get rid of that so we can just see the graph because we don't really need the equation anymore. It's fat, but it doesn't really matter. We can still look at all these points. Okay, what are the questions? At what time does she enter the water? At about 1.9 seconds. That's the X value for when she actually reaches, oh gosh, okay. What was it, 1.9 seconds? Let me see if I can get back to where we were. Okay. What's the next question? B, what is her maximum height? Her maximum height is the Y value of the vertex. So that would be 10.8, I think it's feet. Okay, C. At what time does she reach her maximum height? That's going to be the x value of the vertex, which is 0.4 seconds. Okay, we are going to leave out number 3. I'm really more interested in projectile problems. So we're going to leave out number 3. I think we have one more to do. Okay, I'm going to go over and graph this one and then come back. Actually, I would like for you to graph it as well. So go over and graph negative 16t squared plus 48t plus 10, and then see if you need to change that scale, the x-axis scale. Okay, so mine looked pretty good when I got it graphed. I'm not going to click on this x-intercept because I don't need it. Here's my y-intercept, my vertex, and my other x-intercept when it reaches the ground. A ball is thrown in the air with an upward velocity of 48 feet per second. And so that's where that 48 comes from. Its height after t seconds is given by the function, and then it gives you, and it started at 10. So, all right, how many seconds does the ball reach its maximum height? Okay, so that is the x value of the vertex. So that would be 1.5 seconds. We'll go ahead and do C since we can see it. When does the ball hit the ground? The ball hits the ground at 3.2 seconds. And then our last question, what is its maximum height? That is the y value of the vertex, which is 46 feet. Okay, that's it for this lesson.